Okay, hello everyone. Okay, now I continue the group 17 chapter, okay, by explain the chemical properties. Okay, I start with the relative reactivity of the elements as oxidizing agents. Alright, so refer to our chem book, okay, the relative reactivity of the element as oxidizing agent. Okay, here I already list down the standard reduction potential of fluorine, chlorine, bromine and iodine. Okay, or you can refer to the booklet of standard reduction potential. So refer to this equation given. Okay, fluorine, you can see that the reading is positive 2.87. Okay, and going down the group, iodine is a 0.54 volt. Alright, so here is the fluorine. Fluorine, if you can see that this is the highest, the most positive of standard reduction potential. Okay, so refer to our chem book back. Alright, so now is, okay, from the value given, okay, from the value given, you can see that, okay, fluorine is the most positive, okay, hence, okay, so that one is the most positive, so, right, okay, remember our formula, red cat, which is the most positive, okay, will act as a stronger oxidizing agent, which is itself will occur reduction process. Refer to the chem book. Okay, when the fluorine act as a stronger oxidizing agent, alright, so it is a good electron acceptor. Alright, so all halogens are oxidizing agent, which is the more positive the E naught value. Okay, the most positive the E naught value, alright, okay, the stronger the element act as an oxidizing agent. Alright, for halogen, the oxidizing power decreases on going down the group, since the E naught value less positive when going down the group. Alright, so oxidizing power of halogen can be explained in terms of their atomic radii. So this is the atomic radii, which is, you know that fluorine, right, fluorine is smaller than chlorine, smaller than bromine and smaller than iodine. So we can arrange the oxidizing strength. Okay, for oxidizing strength, we can arrange it that fluorine is higher oxidizing agent, okay, compared to chlorine and compared to bromine and iodine, which is the most stronger oxidizing agent is a fluorine, followed by chlorine, bromine and iodine. Alright, okay, and then, okay, fluorine is the strongest oxidizing agent because its atom has the smallest size. Okay, so the fluorine atom has the greatest ability to gain electron. Alright, so we refer to this our diagram. Right, so this is, let's say this is the fluorine atom. So because of its smaller size, so this fluorine atom has higher tendency to receive electron. Alright, so because of the smaller size of fluorine, it have higher tendency to receive electron, to gain electron. Okay, so same lah. Okay, fluorine atom has the greatest ability to gain electron. Okay, from this standard reduction potential, we can conclude that fluorine is a strongest oxidizing agent. Hence, this fluorine is able to oxidize chloride ion to form chlorine gas. Alright, and fluorine also is able to oxidize bromide ion to form bromine. Okay, fluorine also is able to oxidize iodide ion to form iodine because it is the strongest one. Okay, now refer to our next part. in reactivity of halogen. Alright, so reactivity of halogen as oxidizing agents by adding halogens to aqueous solution of halide ion. Let's say we have three aqueous solution of halogen: chloride ion, bromide ion, and iodide ion. Okay, for this question we cannot use fluoride ion because reactive, extremely reactive. So for fluorine, it does not occur naturally because usually we found the fluorine, okay, in mineral, okay, in a fluoride mineral like cryolite, fluorides. Okay, so we cannot use fluorine as example. Alright, so now, okay, let's say we have three aqueous ion here. Okay, then we want to react it with any halogen. Okay, example, the first example I use chlorine. Okay, the first chlorine I pour into the chloride ion, and then I pour chlorine into the bromide ion, and also I pour the chlorine into the iodide ion. Okay, what will happen? Alright, okay, according to the standard reduction potential, chlorine is the stronger oxidizing agent compared to bromine and iodine. Hence, chlorine is able to oxidize bromide ion to form bromine. Okay, also chlorine is able to oxidize iodide ion into iodine. So, from the first halide, okay, so this is no reaction, no reaction because it's the same, no reaction. Alright, so the second halide ion, okay, how about the reaction? Okay, we have chlorine plus bromide ion. So this is the stronger oxidizing agent, and is able to oxidize, okay, bromide ion to form bromine. Alright, bromine molecule, and itself will reduce to form chloride ion. Alright, so this equation we able to occur lah. Alright, so okay, so then we just balance the equation. So 2 Br here, Br 2 here, and then 2Cl and 2 chloride ion. Okay, so we done the reaction. Then what is the observation here? Okay, so refer to our table. Say chlorine, when we pour into the bromide halide, bromide ion halide, alright, bromide ion, so what we get? Bromine produced, which is the observation is reddish brown solution will be formed. Right, hence we do the second equation, which is chlorine when we pour into the iodide ion, okay, iodide ion. So okay, so because of chlorine is a stronger oxidizing agent than iodine, so it can oxidize iodide to form iodine. Okay, and then chlorine itself will be reduced from 0 to -1. Alright, and then finally we just balance the equation lah. Alright, so this is the second one. So what is the observation here? Okay, what is the observation here? Alright, so refer to the chem book. Okay, chlorine when we pour into the iodide ion, iodine will be produced. Okay, and then the observation, brownish orange solution will be formed. So this time we must refer to the color in a water lah, because aqueous, water is a aqueous. So we just do the observation by referring the color in water. That's why we get the reddish brown. Okay, now we take a look a second situation, which is we using the bromine. Okay, bromine halogen. So okay, let's say we pour the bromine into the chloride ion. Okay, we pour the bromine into the bromide ion. We pour the bromine into the iodide ion. Okay, what will be the observation here? Right, so refer to the standard reduction potential. Alright, so bromine is a stronger oxidizing agent than iodine. Okay, but it a weaker oxidizing agent compared to chlorine. So bromine is unable to oxidize chloride to form chlorine. So it cannot oxidize because it's a weaker oxidizing agent than chlorine. Alright. So from this observation, so bromine, okay, when we react to the chloride ion, so they have no reaction. Okay, the reaction cannot be occur. Okay, and then the second one, bromine, we put into the bromide ion, so for sure no reaction, no reaction occur. Okay, finally we use bromine into the iodide ion. So let's write the equation. Okay, so what happened is, alright, refer. Okay, so bromine ion is able to oxidize iodide to form iodine. So it will oxidize iodide to form, okay, iodine, and bromine itself will reduce to bromide ion. Alright. Okay, finally we just balance the equation lah. Okay, 2 and the 1 is 2. So what is the observation here? Okay, for the observation, okay, we refer to the chem book. Okay, so for bromine, when we pour into the chloride, no reaction. When we pour into the bromide ion, no reaction. And but when we pour into the iodide ion, okay, iodine will be produced. Okay, and the observation, brownish orange solution will be formed. Okay, for the third situation, we use iodine halogen. Okay, we try to put it into chloride ion, okay, bromide ion, and iodide ion. Okay, so refer to this standard reduction potential. You know that iodine is the weakest oxidizing agent compared to other halogen. So for sure that this iodine cannot oxidize all the halide ion. So okay, what is the observation here? Okay, so this one is no reaction. Okay, same goes to in a bromide ion, no reaction occur. Okay, also in iodide ion, no reaction occur. Alright, so refer to our chem book. Okay, so iodine, no reaction in chloride ion, no reaction in bromide, and same goes to iodide ion. So this is the example that we already write earlier. Okay, so bromine cannot oxidize chloride ion because it is a weaker oxidizing agent than chlorine. Okay, let's write one example, okay, of the situation. Alright, when fluorine is bubbled through water at room temperature, a vigorous reaction occurs and a colorless gas that support combustion is liberated. Okay, explain the observation. Okay, from the question given, okay, what is the idea that come out when you get this question? Alright, so the first one is when you see that colorless gas that support combustion, meaning this question is referred to the oxygen. Okay, for sure is oxygen as a product form. Alright, now is the fluorine, okay, when we react with water, we put it into the water, so what will happen? Okay, which compound will act as stronger oxidizing agent, okay, or reducing agent? Okay, so from this question, okay, we must refer to our booklet of standard reduction potential. Okay, refer to the standard reduction potential. Here is the fluorine, which is 2.87, and here is the water equation, okay, which is positive 1.23. Okay, let's write the equation. Alright, like this, I already wrote it. Right, so you know that this is the most positive and this is the less positive, and this is less positive, okay, which is more positive here. So you know that as a red, okay, which is the most positive, okay, will occur reduction. So you know that this fluorine is a stronger oxidizing agent, which is fluorine is able to oxidize water, alright, to form the product lah, to form oxygen gas. Alright, so now is the next step, we can calculate the E naught value. Alright, so the E naught value here is E naught value, okay, equal to E naught, okay, cathode minus E naught anode, okay, which is cathode for sure is a reduction, okay, fluorine, so positive 2.87, okay, minus, okay, positive 1.23, so you will get positive 1.64 volt. So you see that the reading, the E naught value is a positive, which is this reaction is feasible, which is it can occur spontaneously. Alright, so this equation will be occur. So what is the overall equation, okay, from this? So from this reaction, okay, this is the cathode and this is the anode, okay, reduction and oxidation. Then we just rewrite the equation, okay, to F, okay, and then this one we will switch because it occur oxidation. So 2H2O, okay, liquid, okay, form, okay, oxygen gas plus 4H plus, okay, equals, okay, plus 4 electron. Okay, then we balance the electron, meaning that we times 2. Okay, then we times 2. Okay, and then we will get, okay, so the final one is 2F2 gas, okay, we plus 2H2O, okay, to form, okay, 2 times 2 is a 4 fluoride ion, okay, equals, okay, plus, okay, oxygen gas, okay, plus 4H plus. So this is the overall equation. Okay, then from the question given, okay, okay, so the colorless gas that support the combustion, okay, is referred to the oxygen. So from this equation, the overall equation, okay, the oxygen is being released. Okay, then final, we'll just answer the question. Okay, so number 1, the gas liberated, okay, is oxygen gas. Okay, and then number 2, we can deduce that, okay, fluorine is stronger oxidizing, okay, okay, agent. Okay, hence, okay, it can oxidize, okay, water, okay, to form oxygen gas.